The interactive beam design allows you to examine and alter individual beam design in more detail. You can select the beam, then click on this icon. Alternatively, you can double-click on the beam axis. This will launch the beam interactive design. Maximize it. The header of the dialog is reinforcement data. Click on the Beams tab at the top. This dialog shows the constituent of the members and the related information, such as length, clear span and size. These are automatically extracted from the model. There is a 3D diagram below illustrating the beams in the design axis. The selected beam in the table will be highlighted. The side view and the 3D view icon simply changes the direction of the 3D view. In the beam table, you can edit the beam section. If you do this, the beam size will change in the main model. This will result in a change of loading and stiffness of the model. Hence, to get accurate design forces, you should rerun building analysis. Click Cancel. In the support table, the left, I, and right, J, support conditions are also automatically extracted from the model. Although you can change this, be very careful about changing it here, as it means the assumption is no longer consistent with the model you built.
Select Beam GB1 and click Beam Design Parameters.
This will show the key design figures, such as the design moment and shear, and the required steel. The design forces are automatically determined from the envelope combinations of the analysis. If you wish to delink from the analysis and key in your own design forces, you can check Edit manually. Then you can overwrite all the design forces based on your decision. Click Cancel to exit without any changes. Click Rebars tab. At the very top, beams are drawn in 2D as continuous beams, including all span dimensions. There is a curve annotation on GB3 to mark it as a curved beam. The blue figures are required steel area based on the design moments envelope. The extra AS row shows the surplus steel area based on the steel that is automatically selected, shown in the rows of the bottom. Next two bottom rows are AS minimum top and bottom, in accordance with the selected code. S bar stands for spacing of bars center to center. Deflection check shows the length divided by effective depth ratio checks. X support links. If left or right support shear is higher than nominal, the distance of the support region, where higher links must be provided, will be shown. The rebar rows shows the main bars which are automatically selected. The top bars are topmost span bars. At the end span, the top span bars extends to the top support, as we have chosen to extend top support bars to end support in the curtailment settings. The support top bars are provided only over the support. The bottom bars controls the bottom span bars which can overlap into the bottom supports. The support bottom bars are confined only to the bottom support. Web bars are the side bars. Next are the links or stir-ups. Click any links of GB1 to expose detail shear design information, such as the design shear, VD, and V maximum. Torsion is also checked and designed for. For beam GB1, the concrete torsional capacity is sufficient, so no additional torsional links are designed, and nominal links is sufficient. Click on the links of GB3. For this curved beam, the torsional links with closer spacing are required and designed, as the torsion force is larger than the nominal capacity. Click on any other cell to close the shear dialog. Sidebars or web bar is also added, as per code requirement. To check and visualize the beam details, click Detail Drawings icon above. Note the top span bars is extended to the support, as set as default in beam design settings. Similarly, bottom span bars. Review the detail. Close it. Fundamentally, in this dialog, there shouldn't be any red figures, which will indicate failures. Let's try to trigger some failures for illustration. You can manually change or overwrite the rebars. Click on top bar of GB1. Decrease the bar number. Immediately, a red figure is shown in extra, a S row. The figure shown is the amount of deficit. This means the rebar is insufficient. Further, the bar spacing also fails, as shown in the S bar row. This is because the spacing between the bars is now more than the maximum spacing preset. Click to decrease the rebar diameter. Notice now more red figures appear. Now, even the minimum area of steel is not satisfied. Click Select Bars at the top to redesign the beams to the default pattern. You can change the curtailment of the bar. Click on Same Top Bar. Under the steel bars group icons, you can see the left-hand curtailment is Extend Left to Lap, which means the bar will extend into the support of the column. Click on the drop-down menu, change to Extend Left to Short, which means the rebar will stop short of the column. Since the top rebars are short of the column, there is no rebars provided over the support, hence red figures appear in the extra, as for the support region. Reduce the top span bar to 3 numbers of H13, and it is still sufficient at the top span as there is no red figures at this location. Now click on left-hand support top bar cell. Set to 3H16 to satisfy the required steel area at this location and ensure no red figures in this region. Click on Detail Drawing to inspect the change in the beam detailing. As a summary, we have manually reduced the rebars at the top span and provided higher rebars at the support. This may be more economical in total quantity, but will be more difficult to install on site. Close the drawing.
You can also change the bar layers. Click Top Support Bars here. Currently the design is 3H32 in a single top layer. Say, we would like to split to 2 different top layers instead. Change it to 3H20. As expected, this will not be sufficient as indicated by the red figures. Then click on the row immediately below, Support Top Bar 2. Set to also 3H20, which means second layer of support bars is added. The bar line will change to a dotted line, indicating it is auto-placed in second layer. Layer can also be verified and changed by selecting the Layer drop-down menu. Double-check there are no red figures anywhere. Click Detail Drawings to check the detail at this position. Notice there are 2 layers of support bars now. Close it. Click Select Bars at the top to redesign the beams to the original.
If you click on Select Bars drop-down menu, can select other steel patterns for this beam design axis. This allows you to choose any steel pattern for this beam axis, if required. Let's leave it for now. Click Diagrams to view the design diagrams. By default, envelope is shown, which is the superimposition of all the load combination. You can click on any load case or load combination. Click L-2 to show the vertical frame loads calculated on the beams. These are the decomposed slab loads. Vertical deflection can be shown by checking the Delta 2 box. If you want to create a proper report, click Report and choose the desired option. Close the report. Note this diagram is also accessible on the modeling view by choosing a beam on the plan view, right-click, choose Analysis Result Diagram. Exit the diagrams.
Click Beam Design Parameters.
This dialog shows a summary of the design moments in 3 design zones, top and bottom. Shear force and torsion is also shown. The design forces are derived from the envelope diagrams. If you click Edit manually, you can overwrite these values. Click Cancel. By default, the length of the beams in the diagram is not drawn to scale, as shown by the icon Not Scaled. Click on it again to change to scaled. Observe the difference. Previous span and next span are used to move focus of the rebars from span to span. Alternatively, simply use the scroll bar at the bottom. Span length is used to adjust the scale of the diagram. For example, if the texts are too close and it's difficult to read, increase the scale. Click on any bars. The steel bar icons can be used to change the bar's characteristic, such as curtailment, crank and layer, as demonstrated earlier. You can copy the bars of a beam and paste it to another beam. For example, select top span bar of GB3. Click Copy Bars. Select the top bar of GB2. Click Paste Bars. All the top, bottom bars and side bars will be replaced. Design Report will print out the beam design report for this particular beam axis. Click Cancel to discard any changes and exit. Optimize Rebar Layers will automatically assign the multi-layer bar pattern to all the beams in view, according to the ratio set in beam design settings. Filter Axes. You can filter by story, by member labels, by section and by failed members only. To refine the filter, you can multiple select options that appear by holding the control key. These filter functions are very useful if you want to focus on certain elements only, example failed members only. If the model is very large, you may want to filter by stories to batch design beams progressively instead of all the beams in one go. Click Cancel to close without any filter. You can copy and paste bars easily to other beams. Select axis B. A green equal sign will appear next to the beam axis, having exactly the same beam span and sizes. This means that you can paste the rebars to these marked beams. Click Copy Bars. You can paste individually by selecting a beam axis, say axis C, and then click Paste Bars. The rebars will be pasted, and the beams will automatically be checked if it passes or fails. The utilization ratio will be updated accordingly. You can also paste bars to all similar beam axes by clicking Paste Bars to All. However, we will not do this since this will likely be insufficient for some beams. We have completed the beam design. You can close the beam section design menu.
Review beam design settings. If settings changed, beams must be redesigned using Reselect Bars. Rebars are automatically designed to major moment, major shear torsion. Minor moment, minor shear tension not designed, they are checked against user-defined, ignorable forces. Deflection is always checked, not auto-designed. In the interactive reinforcement design data, bar size, number curtailment can be changed. Ensure no red figures as it indicates failure. Although beam size can be changed, rerun analysis for updated forces. It is good practice to design beams progressively as you build model. Gravity results of beams are not significantly impacted by other stories. Lateral loads have more impact, although small for short buildings. Use filter function to design in small batches, example by story.